Okay, this is an example of a straightforward titration reaction. In the reaction, H2SO4 plus NaOH gives Na2SO4 plus H2O. The equivalence point, remember that's the point when you have exactly reacted the reactant to the product and there's no excess of either reactant left over. Anyway, the equivalence point occurs when 23.0 milliliters of 0.2055 molar NaOH is added to a 25.00 milliliter portion of H2SO4. What is the concentration of H2SO4? Oops, and I forgot one right here. That's a 23.10 milliliter portion. Okay. The first thing to realize is that if you look at that equation is unbalanced. So watch out if your hydrogen has a 2 or a 3 or a 4, or if your hydroxide were to have a 2 or a 3 or a 4, chances are you will have to balance the equation, and they might not always tell you to do that. So watch out for that. In this case, it's pretty straightforward. We have 2 hydrogens, so we need 2 hydroxides in order to neutralize that, and that will give us 2 waters. Okay, any titration problem, you're going to go from whatever is given, whatever given information you have for your known, info, you will convert that into moles of your known substance. You will then convert it into moles of the unknown substance, and then from there you will convert it into whatever you're asked for about the unknown. Okay, titrations are simply stoichiometry problems. All right, and the key to a stoichiometry problem is this middle portion here, where you're converting moles of a known substance to moles of your unknown substance. And in order to do that, you will be using the mole ratio from the balanced equation. If you are really lucky, your ratio will be 1 to 1, but in this case, your ratio is going to be, there's no coefficient, so that's a 1. And there is a coefficient here, and so that's a 1 to 2 ratio. Okay, so any titration problem will be along the lines of this 3-step process. Convert first into moles of your known, second, convert into moles of your unknown, and third, you're going to do whatever the question asks you for with those moles of unknown. Okay, so let's do this. What is our known substance here? Pause the video and think about that for a moment. The known substance is 23.10 milliliters of 0.255 molar NaOH, because we know everything about it. We know milliliters, we know molar, the molarity, the concentration. So the given info that we have is that we have 23.10 milliliters of 0.2055 molar NaOH. So NaOH is our known substance. That means in step number 1, we are going to find the moles of NaOH, our known substance. And then in step number 2, we are going to convert to our unknown substance, which in this case is our other reactant, and that is our H2SO4. Moles of H2SO4. And then finally, we have to look back at the question and say, what is the question actually asking me for? It's actually asking me for the concentration of H2SO4. Okay, so we are finding the concentration of H2SO4. And what is the unit of concentration? Pause the video and answer that for yourself. The unit of concentration is molarity, which is though hiding the fact that we want moles per liter, which is kind of nice because that means we can take our moles of H2SO4 and then we'll divide it by whatever our volume of H2SO4 is there. Okay, so let's do this. I am going to work in millimoles to save that extra conversion step. So we are starting with 23.10 milliliters times 0.2055 moles per liter. And what is that moles of? That is moles of NaOH. Step number 1 is now done. Liters cancel, and remember we still have that little milli right there that will carry on with us through the whole question. Step number 2, let's convert this into moles of H2SO4. And we want to cancel moles of NaOH. And so we now have, go back, remember when you're converting from moles of one substance to moles of a second substance, you're going to be using the mole ratio from the balanced equation. So go back to your balanced equation and say, what is the ratio between NaOH and H2SO4? It is a 1:2 ratio. We use 2 NaOHs to react with every 1 H2SO4. So there are 2 NaOHs that react with every 1 mole of H2SO4. Okay, that cancels that. There we go. And at this point, I'm going to put an equals sign. I'll show you how to do it all in one line a little bit later if you're interested. But for now, that is going to give us, and I'm going to cheat and look at Hebden, and that gives us 2.3735 moles, not just moles, millimoles. Come here. There we go. Millimoles of H2SO4. Because remember, we have the milli and we have the mole, and those are the only things that haven't been canceled out yet. Okay. Now we want to find our concentration. Oh, by the way, step 2 is done. Now we want to do step 3, which I didn't number. We want to find our concentration of H2SO4. And so concentration is molarity, which is moles per liter. So we want the moles of H2SO4 over the volume of H2SO4. And so that is going to be, oh, why am I going up? Moles of H2SO4, so right from here, plug that in, 2.3735 millimoles of H2SO4 over, and we will use milliliters here so that the milli cancels and we'll be left with moles per liter. Where are milliliters? There we are right there. 25.0 milliliters of H2SO4. So that's the volume of H2SO4 that contains the millimoles we calculated. So 25.00 milliliters of H2SO4. Okay, and we get 0.09494. And what is our unit? Let's just check it out. The millimoles cancels with the milliliters, and we are left with moles per liter. So that's going to be moles per liter, or we can simply write it as molar H2SO4. Okay, so just reminding you, the general way to solve a titration problem is to take your given information, convert it into moles of whatever your known is, convert it into moles of your unknown substance, and then look at your question and figure out what do they want me to do with those moles. And if you don't want to know the way to do it all in one line, you can just stop with this example for the day. If you would like to see it all in one line, let's do it that way. Concentration of H2SO4 is equal to, and we'll do the same calculation that we did before. We have our 23.10 milliliters of NaOH times 0.2055 moles of NaOH per liter. Liters cancel out. Times, now we're going to use our mole ratio from the balanced equation. 1 mole of H2SO4 per 2 moles of NaOH. Okay, moles of NaOH cancel out. So right now what we have is we just have moles of H2SO4. And remember, concentration is going to be the moles of H2SO4 over the liters of H2SO4. So how am I going to do this in one line if I want to have my liters on the bottom? Well, one way to do it, there are others, but this is one way, is that you can simply say, well, I want my liters of H2SO4 on the bottom, so I'm going to put my 25.00 milliliters of H2SO4 on the bottom. And check it out, our milli here cancels with our milli here, and we will be left with the moles of H2SO4 on the top and liters on the bottom. We're left with moles per liter, and our calculation will end up exactly the same, 0.09494 molar H2SO4. Thanks for playing. I will see you next time.